All right, so we've introduced the idea of the trig substitution. It's basically to replace the variable x here with an expression involving the trig function sine. Okay. So let's consider an example here where we have that. This time a is force 1. This is just the antiderivative. The 1 minus square root is actually just the derivative of the inverse sine. So the antiderivative of this stuff is the inverse sine. But let's see how this substitution idea plays through here. So we begin by making the substitution. Let x be equal to a sine theta. So in this case, just sine theta. Then we still need to differentiate because we got to also account for dx. Dx then be the derivative of sine, which would be cosine theta d theta. So writing that in, we would have the integral of 1 over. So replacing x with sine, we would have 1 minus sine squared theta. And then dx will become cosine theta d theta. So we've changed from the x variable over to the theta variable. But now sine squared, 1 minus sine squared is just cosine squared. So we're going to have square root of cosine squared theta. And then on top here we have a cosine theta d theta. And well, square root of cosine squared, normally that'd be absolute value, but when we do these problems, we treat it to be positive. So what we can realize here, square root of that's just going to be cosine. And that's going to cancel with the other cosine. So we literally now just have the integral of d theta, which is just theta plus a constant. Okay. And then we have to go back here and say, well, we need to convert back to x now. So what we do is we realize that when I solve for theta here, I'd have to apply inverse sine to both sides. And I would get that theta is equal to the inverse sine, of x. So theta is just inverse sine or arc sine of x. Either way, you can use either notation. I'm personally partial to the arc sine version myself. This cancellation also works here because remember, when we're dealing with inverse sine, theta equals inverse sine. Inverse sine is tied to the first and fourth quadrants where cosine is positive only. So making this become just cosine does make sense. Okay, and so we just get the arc sine. Okay, so of course that's one you might have memorized, the derivative of arc sine. But we can see here how it flows through very nicely through the substitution process without remembering that. And the nice thing about this is it'll account for the other pieces if there were other things involved in here that we could deal with. So, okay.